Hello everyone. Today we are going to see about an experiment of how to implement the hidden Markov models. So let's get into it. First, let's discuss about the objective of the experiment. The main objective of this experiment is to demonstrate how the hidden states can be predicted using the observed sequences. So that's what is given here. We are going to implement this hidden Markov model using the Python and to determine hidden weather states from observed sequences. So here we're going to get an example of weathers, and then from the weathers the sequence could be anything like happy or sad. So after that, to calculate the probability of observations using HMM and to break the most likely sequence of hidden states. This is what I have said, the hidden states. Okay, so let's get into it. So the program implementation is this only. We have been implemented this experiment using Python language, and we'll be using NumPy library for it, which you can see it here. And we have defined four major and important matrices which contains the probabilities, which is nothing but transition matrix, emission matrix, initial probabilities, and observation sequence. You could also see it here. And the main important thing for these matrices is nothing but first is transition matrix. So transition matrix defines the probability of moving from one hidden state to the another state. So that's what will be given here from 0. 0.7, 0.3, 0.4, and 0.6, which forms a 2D matrix. And then we have is initial probabilities. Initial probabilities is nothing but a normal probabilities for each hidden state, and an observed sequence which we have been using for our prediction. So that is nothing but 1 1 1 0 0 and 1. And finally the emission matrix. Emission matrix is a matrix that defines the probability of observing a particular output of a hidden state from a hidden state. So after that we'll be having the alpha values. So this alpha matrix is calculated to determine probabilities step by step for each observation. So that is why we'll be using the for loops two times for getting the step by step observations, and we'll be storing it in the alpha variable. This is also an kind of a matrix format. And also the loop updates the probabilities using transition and emission values. So and finally, we'll be printing the probability of observed sequence after finding the probability using the for loops of updating the alpha value, and then we will be finding the most likely sequence, which is nothing but the hidden sequence of the model. So that's what we'll be doing it here. So we'll be appending whether it's sunny or rainy. It's nothing but the hidden states that we're going to observe it, or we're going to predict it using the observed sequence. So let's execute it and check it. This is what our code is. So let's run each and every cell, and then we'll be getting a clear idea about it. Yeah, we have got our observed sequence value, the probability of the observed sequence, which we have it here, and that is nothing but 0.0189 and so on. So by using this, we'll be finding our most likely sequence, which is nothing but the sequence that we will be predicting it. That is what we'll be running it here. So here you could find the most likely sequence of weather states in sunny, 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 rainy, rainy, and sunny. That is nothing but the observed sequence what we have got, 1 1 1 0 0 1. So this is how the implementation of HMM works. So after that, applications of HMM. So there are many applications of HMM is available. And for example, we could say speech recognition, weather forecasting, and NLPs, and also in bioinformatics, AI-based prediction systems, and activity recognition systems, and chatbots and virtual assistants. This is mainly used for predicting the future states future hidden states by the observed sequence that we already have. So obviously we'll be using this for predicting anything that is for our present and for the future. Thank you.